Okay. All right, it's popping up. Yep. And there we are. There we are. Okay. So I'll make sure that you guys can see it. Okay. So now we're going to go ahead and start. So with the lesson that we're going to do today, it deals with the ICE charts. I've received so many different requests for that. So for those of you all that are here, I'm trying to wait before I start and get into the lesson, because I know once I start, there are going to be folks that are going to ask questions, and you all know I love to answer your questions, but I want to make sure that when I do answer your questions, that it's not while I'm doing the problem sets, because I know sometimes that can serve as a distraction for some of you all. So I'm just going to wait about 60 more seconds before we actually go ahead and get into our unit for today. Okay. So I hope you all are doing well today. It's been a long week, to say the least. I know that so many of you guys are stressed right now, and I get it. I truly do get it. I know that when you're getting close to the end of the semester, you want to give up, but you cannot give up, okay? You cannot give up. Now, here's the thing though, and let me flip my camera to me so I can say this. So many of you guys are going through a whole lot this semester, right? Yes, I get that. But here's what you got to remember, that as you're going through a lot, you've got to keep pushing. Don't stop. Keep moving forward in the direction that's going to get you to get out of this chemistry class. So for those of you all that are on here, if you don't know who I am, my name is Professor TK the Chemist, and I am a actual college chemistry professor, but I also do STEM outreach programs for students from kindergarten to high school. So I try to encourage them to go into the STEM profession, So by day, I'm a professor, but in the afternoon, I am a STEM outreach consultant, and I show the kids all the fun things that they can do while they're learning chemistry. Now, I know that one day they're going to go into high school and they're going to have to take chemistry. I also know that as they graduate from high school, they're going to have to take chemistry if they're going to college and if they're pursuing a science-based profession. So I do these experiments, I do chemistry problems, because I want to make sure that those of you guys that are currently enrolled in a chemistry class, that you can understand the information that you need to know for your class, okay? So I'm going to go ahead and flip my camera back to show you all why that's important. It's important because some of you guys may be currently in a nursing program, or you may be in engineering, whatever the case may be. You're going to have to do problems such as the ones that I have up here for you all. And what I do know is that based on these problems, they're going to appear on your final exam. They're going to appear on your next quiz or homework or test. And so what I've got for you guys on the screen today deals with the ICE chart, because I keep getting those requests. So that's why I'm going to do this afternoon. Now, something else I want to kind of point you guys out to is that in order to understand the ICE chart or the ICE tables, you've got to do what? You've got to figure out what these equilibrium constants are all about. So as you guys kind of walk through and you see what we're doing here, okay, you're going to know why this is important, okay? So let me go ahead and start you guys off with a couple of things. Make sure you got your calculator, your pen, your water, but in my case, I'm drinking some cinnamon tea, okay? And your mindset. Make sure you got those things prepared to get into our lesson today. Because here's the thing, if you don't want to do it, guess what? You ain't going to do it. It doesn't get any easier, okay? So you got to do what you got to do in order to go where you're wanting to go, all right? So I also want to go ahead and give a couple of shout outs also before we get into the lesson. Several of you guys have been reposting my videos. You've been tagging me and all that good stuff. And I just want to say thank you. I appreciate all of you all who have supported me this semester and me going live every day, Monday through Thursday. at 12 noon. That really means a lot to me. So those of you guys that have been sharing my lives and you've been tagging me, and you've been tapping that screen, I just want to say thank you. I really do. I know there are thousands of other chemistry tutors on this platform, but you all have chosen to hang out with me 12 noon Eastern Standard Time, Monday through Thursday each week. So if you guys ever need any help, you guys know where to find me. Just tap that link in my bio and I got you covered, okay? I got you covered. Now, occasionally I will be drinking my tea, my cinnamon tea. So if I pause, that's what I'm doing. I got to catch my breath. Okay, speaking of breath, I also worked out this morning. What I have found is that I do better working out in the morning time. And I know a lot of times when you guys are stressed out, go walk it off. Go walk around the block. Go do something that's active, because sometimes you cannot see certain problems because you're stressed out. Okay, you're stressed out. So if I were you, I would go ahead and, go walk around your room, walk around your apartment building, go climb your steps if you have steps in your house or in your apartment, and then come back to your lessons. Sometimes you have to hit the reset button in order to understand what you're doing. Okay, so those are just my little tips and tricks to kind of help you get into your lesson for that time period. So are you guys ready? I'm ready. Let's go ahead and start. What we have here today deals with chemical equilibrium. And with chemical equilibrium, you've got problems that deal with setting them up, okay, in a manner that's going to allow you to know what you have to do. So in a problem like this, one thing we have to figure out and do and understand is that when it comes to chemical equilibrium, it's always going to be your products, okay, over your reactants. Now, we've discussed this before. We have discussed this before. When we say your products over your reactants, you've got to make sure that you know what your products are, okay? You got to know what your products are. Now, you also want to keep in mind that whatever your products are, you're going to raise it to those coefficients, okay? You're going to raise it to the coefficient. So that means if you're talking about the products, okay? Let's just say hypothetically, and again, this is not a real problem. This is giving an example. Let's say that you're looking at concentration of A and the concentration of B, and those happen to be your products. And then the reactants were concentration of C and concentration of D. If there is any type of coefficient in front of your balanced equation, you have to raise it to that particular value, okay? You have to raise it to that particular value. So let's just pretend like B was had a coefficient of 4 in front of it when you balanced your reaction. And let's say that D had a coefficient of 3 and A had a coefficient of 2 and C was just 1. You have to also make sure that you incorporate your coefficients as the power of that, okay? As the power. So that's just an FYI in terms of what we're going to do based on this process, okay? So I'm going to go ahead and erase this because this is not the correct stuff for this particular problem. I just wanted to kind of give you all the background. So in this particular problem, they're wanting you to use the reaction A plus 2B at equilibrium that produces C plus 2D. Okay, here's what you got to know. The reactants are on the left side, okay? If you don't know your reactant side from your product side, all of your numbers are going to be wrong. Your products are on the right side, okay? So in this particular example here, because you're doing products over reactants, you're going to say C, the concentration of C, times the concentration of D raised to that power. There's a 2 right there in front of D over the reactants. So you have A, concentration of A, times the concentration of B raised to the power of 2 also. Now, here's something else you got to keep in mind. They want you to find the equilibrium constant, meaning the KEQ. And some of the problems that we will do, they'll provide that for you. But in the problems that they don't, and they're giving you the concentration values for each of your reactants and products, then what you have to do is plug in the concentration values for each of them. So I'm going to go ahead and scroll down on my screen here so that we can go ahead and plug those numbers in, okay? So for my KEQ, let me zoom out a little so y'all can see the full screen here. For my KEQ, I'm going to put my C, which is 0.0003378 molarity, times your D is 0.0006756 molarity, but that is squared, divided by A, which is 0.0567 molarity, times B, 0.1171 M, and that's also squared. Okay, now what I'm going to do, I'm going to go ahead and get the value for the product side, okay? And I'm going to get the bottom numbers as well. So for my KEQ, okay, let me go ahead and multiply the zero. Well, okay, first I'm going to square this value here, the 0.0006756. So I'm going to go ahead and square that before we go any further. Okay, 6756, and I'm going to square that. That's squared times 0.0003378. Okay, so I'm going to write that top number in. That top number needs 4 significant digits. So the top is 1.542 times 10 to the negative 10th power. All of that divided by, okay, let's go ahead and square the next part of that 0.1171. We got to square that times 0.0567. So for the bottom number, I only need 3 of those numbers. So on the bottom, 7.77 times 10 to the negative 4th power. In chemistry, you have to make sure, it's okay. In chemistry, you have to make sure that you take care of your top row and the bottom row. You should write everything out so that you know that if you make a mistake, you can go back and check your answers, okay? So now I'm going to go ahead and plug in that top number again, 1.542 times 10 to the negative 10th power divided by 7.77 times 10 to the negative 4th power. And I get, and I only need 3 of those numbers, 1.98 times 10 to the negative 7th molarity. I'm sorry. Actually, the molarity, the M goes away. Whenever you have a constant, the constant doesn't have a unit, okay? And how do you know that the units go away? Look, M squared here and M squared there goes away. The M's here goes away. So that's how you end up with no unit for your equilibrium constant. And they call it a constant for a reason. I'm going to pause so I can get my water. Okay. Yes, so thank you so much, WYU. I like to show proof of what I'm typing in so y'all don't think that, you know, I'm not plugging in the right values. I want y'all to see it. YouTube, same thing. That you all may not be able to see it because I have a little video going on with my picture right here. Okay, but yes, thank you so much for that. Now, also, I'm going to show y'all that that answer is also correct. So you guys will know I'm not pulling your leg. So this is chapter 20 right here. This is a workbook that I'm using. I have tons and tons of chemistry books. So I pull problems from everywhere, from everywhere. Okay, so that was problem number 1.98 times 10 to the negative seventh power. Here you go, 1.98 times 10 to the negative seventh power. I know you probably can't see that. It was probably blurry, but yes, that is the answer. Okay, let's go to the next problem, okay, in that same section. Does anybody have any questions so far? Are you lost and need to be found? Do you need me to GPS you back here? Do you need me to GPS you back? Oh, wow. Okay. Yes, I know this is not going to be helpful to you right now when I say this, but I will be doing electrochemistry next week. So, and remember, you can always see it on your final exam. So even though I'm not working on electrochemistry right now, yes, I will be doing that next week during my lesson for tutoring. So for those of you all that need electrochemistry, I got you covered. It'll just start on Monday. Okay, I just came in, was the square because there was a 2 coefficient. That is correct. You are absolutely correct. Yeah, that is correct. So I'm actually going to start this one. So you came in right on time. So you can actually see me do this next problem. Okay, so let me zoom in. So you're welcome. You're welcome. So right here, we're dealing with the equilibrium constants because some of you guys have had requests for me to do that. So let me go ahead and show you all this next problem. Now, when it comes to this particular example here, okay, you've got, again, products, reactants. Remember the formula, KEQ equals the products over the reactants. And whatever the coefficients are, you have to make sure that you raise it to the top. So Juju says, will you be doing this later today? I'm at work, but I struggle with the ice tables and equilibrium constants. Yes, matter of fact, Juju, I got several problems on my YouTube channel as well as this TikTok here. So you can go back and look at the ice charts, anytime you want. And yes, I will have this posted. But I do have several problems already on my YouTube channel. And if you're not subscribed, go ahead and subscribe so you'll remember to come back. But I appreciate your concerns. And but I do have them for you on my TikTok channel as well. Thank you, Tam Tam. So what we're going to do now, again, your reactant, even though this was reversed, you have the reactant on the left side is still the same, and your product, the end result, is still on the right side, no matter how your chemical reactions look. This is a decomposition reaction. So you have some made up element A, or compound A, rather, that's in equilibrium with C and D, producing C and D. Now, here is the thing, though. You're going to say your equilibrium constant equals your products, which is C raised to the power of 2 times D raised to the power of 2 over A raised to the power of 2 as well. So as you guys can see here, you are still looking for your equilibrium concentrations, and all those squares are there. You're going to simply plug in those numbers that they're giving you. So A, C, and D, there is no B here. A, C, and D are the numbers that you're going to plug in to your problem, okay? So the equilibrium constant here is going to be your C squared times your D squared over your A squared, okay? So what we're going to do, we're going to say 0.0004104 M, and that's squared, times D, which is 0.0004104, and that's also squared. Now, I know that I probably need to scoot this over, so let me go ahead and Uh-oh. I need to scoot this over. There we go. You know what? Let me just start this part over because I wrote it so big that it caused some distortion where you can't see the whole thing. So let me just write it over. Yes, because I ran out of space. Okay, so the C is equal to 0.0004104 M squared. And then your D is the same number, 0.0004104 M. And that's also squared, divided by A squared, 0.1077 M. And that's also squared, okay? So now what you're going to do is go ahead and multiply or square rather the top numbers, okay? Since this number is the same thing, you're going to square that number and you're just going to do it twice, okay? So let me plug this number in right here so you all can see that. 0.0004104, and again, that's squared. So I'm going to write this in right here. That's 1.68 times 10, 1.684, because we need 4 sig figs, times 10 to the negative 7. And you're going to do that again. That's going to be the same answer for this other one because they're the same number. Okay, so that's 1.684 times 10 to the negative 7. And you're going to multiply those two numbers. And then on the very bottom, let's square that one too. Okay, 0.1077 squared. And we get for the very bottom 0.01160, because we got to make sure we have the appropriate number of significant digits. Now, I'm going to go ahead and multiply these two numbers together on the top row so that I'll know what that's equal to, okay? So that's 1.684, 1.684 times 10 to the negative 7th power. Multiply that number again. Okay, and on the top, I get 2.836 times 10 to the negative 14th divided by 0.01160. So let's plug that in and see what we get for our final answer. When we divide those two numbers, we get 2.444, or we can just round it out to 5 because we only need 4 significant digits, okay? 2.445 times 10 to the negative 12th power. Okay, that is your answer right there for the KEQ, equilibrium constant. Okay. Any questions so far about any of these problems? Any questions? All right. Now, let's take a look at this next one, okay? So for this one right here, let me go ahead and cut it up again so we won't be looking at B. We're going to concentrate on letter A, okay? So right here, they're giving you some background information, okay? They're telling you that nitrogen monoxide reacts with oxygen, and then it's in equilibrium and it produces nitrogen dioxide. Here's the deal, though, with this. They're giving you the concentration of NO and O2. They gave you the equilibrium constant, but now they want you to look for NO2. So now they want you to find one of the concentration values. So now you're probably wondering, all right, so what are we supposed to do? Well, let me show you. It's not that bad, guys. I promise you it's not. It's like this. If you know A plus B equals C, and we just calculated C, What happens if I tell you that A plus some number equals C? So if I say A plus B equals C, okay, and let's just say that A is 4 plus 1 equals 5. Well, what happens if I say A plus what number? Well, let me write that a different way. What if I say 4 plus B equals 5? How do you know what B is going to be equal to? Then you have to subtract from both sides, right? Yes. So that's the same thing. You're able to assess your problem based on what's given, okay? I just wanted to kind of point that out because when we do this next problem, you're going to be able to do that. That girl that looks mean says, good morning. Can you go over the subject of intermolecular force? Well, today I'm actually doing equilibrium constants, but if you can do me a favor and put that on my last video, I will remember to do that for you. And it may not be today, but what I can do, if I'm not able to go live and do it, I will make sure to do a video response to you personally, okay? So and I'll tag you in it. So just make sure that you put your question on my last video and I'll do a video for you, okay? Now, on this problem here, going back to this one that said 7A, we're going to do what? Again, we know that the formula, okay, thank you so much. We know that the formula, yes, it is products over reactants, okay? Raised to their powers based on their coefficients. Yes, and we know that, right? But here's the thing though. In this particular case, here's what they've given us. They gave us the equilibrium constant, which is 1.671 times 10 to the 4th. They also gave us the concentration of NO and the concentration of oxygen. They want you to find the concentration of NO2. So that's what I'm highlighting. What's in yellow? That's what you need to look for. So I'm going to plug these values in. The K constant that they gave us here was 1.671 times 10 to the 4th power. Whoops. Equals the products. Okay, so remember, your reactants are on the left, your products are on the right. So the product here is NO2, and that's square, okay, divided by the concentration of NO, which is 6.200 times 10 to the negative 2nd power, and that's squared. All of that times oxygen's value, which is 8.305 times 10 to the negative 3rd power, okay? So what you know here in this particular problem is that they've given you the concentrations of your reactants and your equilibrium constant, but you're looking for one of the products. So here's what you need to do, okay? Don't blink. I want you to watch what I'm getting ready to tell you to do. We're going to take these two bottom numbers right here, and we're going to multiply them with this number here. So we're going to basically merge those two together, and we're going to multiply them. Okay, so watch this. I know you're like, oh no. And I'm like, oh yeah, okay. So watch this. So let me write the formula so that way you will know what I'm referencing. I'm going to say the KEQ that they gave us, okay, times the concentration of the reactants. The reactant was NO, okay, squared, times the concentration of O2. That's equal to NO2 squared, okay? So what we've got here in yellow, and let me go ahead and highlight that, we're going to multiply those three numbers. And that's what I'm talking about right here, okay? We're going to multiply those three numbers. That's why I put that there, okay? So watch, don't blink. Watch. So let me go ahead and rewrite the numbers in right here. KEQ was 1.671 times 10 to the fourth power times NO2, which was 6.200 times 10 to the negative second, that's squared, times 8.305 times 10 to the negative third power, okay, equals, and I'm just going to put x squared. I'm replacing the NO2 with an x to say that we're looking for that, okay? Now, be patient, because I'm getting ready to show you what we're getting ready to do. I'm going to go ahead and square this number right here, the 6.200 times 10 to the negative second power squared. Now I'm going to multiply that times the 1.671 times 10 to the fourth times 8.305 times 10 to the negative third. Okay, we're going to write that number in. 0.5335 equals x squared. But guess what? We're going to take the square root of this answer here because we want to get rid of that, okay? So I'm going to take the square root of that number. To get rid of this x squared, square root of that. So this x is equal to the square root of 0.5335. And this is equal to, let's square root that, 0.7304. And that's M, okay? That is the concentration for what we were looking for NO2, okay? That is your concentration. Did I lose you? Did I lose you? Are you good? Okay, and again, let me show you the answer so you will know. This was number 7A, right there. You see that number? 0.7304. Okay. All right. We've got our last problem in this section, because remember, that was a part A. Okay, that was part A. Now we've got to do part B, okay? Part B. So let me go ahead and scoot this one. Uh-oh. Okay. It's always something when I'm trying to align these problems and get the second page to come through. So hold on, y'all. Okay, let me just get another sheet, okay? That'll be most helpful. This is part B. Now, what I'm going to do, thank you, Goddess of Gemini. I appreciate that. Thank you so much. Thank you, thank you, thank you. Now, here's the thing. For number 7, even though this is a two-part question, okay, whatever you did in letter A has nothing to do with part B in terms of using those numbers unless they tell you otherwise, okay? Unless they tell you otherwise. So I'm going to rewrite the formula, or the chemical reaction rather, okay? And now, right here, thank you, Marguerite Jackson. Oh, I appreciate that. Y'all are so sweet and kind. You know what? I'm the teacher, the professor that I wished I had in undergrad. My professors made things so difficult. They sure did. They made things so difficult. And that's why I take my time, because I want to make sure that you all understand it just like I wished I could have understood it the first time. So right here, they're telling you that at 1,000 for part B, at 1,000 K, that's Kelvin, that's the temperature, the equilibrium K for the same reaction is, so in other words, they're giving you a different equilibrium concentration here, okay? What will the concentration of NO2 be at 1,000 Kelvin, given the same concentrations of NO and O2 that were in part A? So here's what I'm going to do, okay? I'm going to write down the concentration values. So NO, okay, equals 6.200 times 10 to the negative second power, M. And my O2 right here, okay, is 8.305 times 10 to the negative third M. And they're wanting you to calculate NO2, okay? That's what they're wanting you to look for, but they also gave you a completely different K, okay? So you got to make sure that you use the given numbers based on what they're telling you right here, okay? So that's what I'm doing now. I'm just copying everything down to make it easier for you guys to kind of see, okay? So the K in this particular part, because remember, it's a completely different temperature also, okay? So in this particular case, let's see what they gave us. Right here for letter B, 1.315 times 10 to the negative second. Okay, so I've got all that information, right? So I'm going to go ahead and start solving for the problem. And they want me to look for NO2, okay? So given this information right here, let's see what we got to do really quickly, okay? And when I say really quickly, I'm not saying we're going to rush through the problem, no. So let's go ahead and find the answers here, okay? And let's set it up the way we know how. Remember, in this particular problem, you're going to have to do what? You're going to say your K EQ, okay, equals your products raised to whatever power it is, if there are any coefficients, divided by your reactants raised to whatever power that they have as well, okay? And in this particular case, they have given us clues of what they want us to do. So remember, this is your reactant side, and then this is your product side, okay? So they told us that our KEQ for this one, okay, was 1.315 times 10 to the negative second power. That's equal to my product, okay? Remember, the product is what you're looking for. In this case, is NO2 squared. We're going to divide that over the reactants. And the reactants in this case, once again, was 6.200 times 10 to the negative second power squared times 8.305 times 10 to the negative third power. Okay? Now, since we've already calculated this information on the very bottom, okay, here's what we're going to do. I'm just going to go back and pull the information that I had from my previous problem, okay, for the sake of time. But I am going to show you how to set this up, though, okay? Remember, we are going to take the bottom row right here, and we're going to multiply it times this value right here, okay? We're going to multiply those two together. We're going to multiply them, okay? So and again, for the sake of time, NO2 squared equals X squared, because remember, we're going to say that's equal to X. That's equal to 1.315 times 10 to the negative second power times 6.200 times 10 to the negative second squared times 8.305 times 10 to the negative third power. Okay, we're almost done with this problem. Okay. So I'm going to take that 6.200 times 10 to the negative second power, and I'm going to square that, times 1.315 times 10 to the negative second power, times 8.305 times 10 to the negative third power. All of that is equal to this number right here. X squared, which again, you're looking for your NO2, is equal to 4.198 times 10 to the negative 7th. Now remember, we want to get rid of that square, so we're going to take the square root of both sides, and that's going to give us the answer, the final answer, okay? So X is going to be equal to the square root of that answer right there. So let me go ahead and take the square root of that, and that's equal to 6.479 times 10 to the negative fourth power, and that's the concentration for NO2 in this particular part. And let me show you the answer in my book so you know that this is the real deal Holyfield. All right, right there. Letter B, 6.479 times 10 to the negative fourth molarity. Okay. All right. So are there any other questions, guys, for any of you all based on what we've done today? Any questions? So we did several different examples. Several different examples. Okay, Mishmash said, how would you find the unknown substance based off of pH and concentration info? Okay. Are you saying in reference to like what we're doing here? How would you find the unknown substance based off of pH and concentration? So, because here's the thing, you would have to be given, information in order to do the problem. Like okay, so like in this example, let's just take this as an example. If I said find the equilibrium concentration for this whole chemical reaction, you would have to know the concentrations for all of them in order to solve this particular part of the problem. Okay. Yes. Who the person that just answered that question? Yes. Okay. So Mishmash, can you DM me like your question? Okay. Because maybe I'm not. Because again, the thing is, yeah. Okay. Thank you. Thank you. Because see, the thing is, when it comes to concentration values, let me see if I can pull up one. Let's see for pH. And maybe this can explain what you're talking about. Because I know even with pH, you would have to know one in order to kind of like dial back and work backwards to find the other. So yeah, and as long as I know what question you have a little bit more to be more clear, then I can answer your question. Okay, so guys, I know that this has been a long week, as I've said before, and a lot of times you guys are getting close to the end of the semester and you're getting a little antsy, in terms of how you're going to do in your class. But again, like I said before, don't give up. Okay, don't give up. Matter of fact, let me show you, let me tell you why you don't give up. Just because the problem is hard doesn't mean that you should give up, okay? Matter of fact, here's what I recommend that you all do. Let me scoot back a little bit because my face all up in the camera. Okay. Here's what I recommend that you guys do. Go to your professor during their office hours. If you haven't been to your professor all this semester, however, no love is lost. You still want to show the effort, okay? You still want to show the effort because a lot of times chemistry professors, well, I'll say professors in general, we love when you guys come to us and you tell us that you're having trouble, but we want to be very helpful to you as well. So you've got to come with your questions prepared. So if you show up in my office and you say, I don't understand none of this, I'm going to look at you like, well, where do we need to start? So you need to make sure that if you have questions, that you come and at least attempt to do the problem. You at least show that you're trying to do the problem. Show some of what you want to know and try to get through it together with your professors. Go to the tutoring center also. Do you all know some professors give extra credit points for going to the tutor center? Now, they may not tell you in class that that's what they're doing, but when it comes time to giving you your final grade, and let's say that you had a 69, you didn't pass that class. A 69 is considered a D, at least for my school, because we're on a 10-point scale. And if you get a 69, you didn't pass. But if you came to my office hours and you emailed me your concerns and you attempted to try to meet me halfway, I'll go ahead and hook you up with that extra point to get you on out of here because I know you were really, really trying. Closed mouths don't get fed. Remember that. Closed mouths don't get fed. If you don't move your feet, then we don't eat. So we like neck to neck. Outcast. So what does that mean? You got to put in some effort to get the responses that you want from that class. And by all means, if it's still not clicking, if those cylinders are still not clickety clack clack, then you need to hit the link in my bio and come see me virtually to get you some one-on-one chemistry help, okay? I make sure to take my time with you during your tutoring sessions, and you will also get a copy of the recording of our lesson. So if you want to go back and look at it again, you sure can, okay? So just make sure that if you guys are on the struggle bus, get off that struggle bus and come onto my bus where we're going to make sure that you succeed and pass with confidence. It's not too late. You still have your final exam and possibly one more test and your lab experiments because all of that goes together with your grade, okay? So as I always say, don't stop, get it, keep pushing, and don't give up, okay? It's not over. And if you've passed the withdrawal time for your class, then you just might as well stick it on out, okay? Just stick it on out. So you guys take care and you all have a wonderful rest of your day. I appreciate all the shares, all the follows, and stay tuned because I will be going live again Monday. I go live Monday through Thursday, Eastern Standard Time, 12 noon. And that's why I call it Lunchtime Chemistry with Professor TK the Chemist. Okay? And again, for those of you all that want to go back and watch the video, you can see me here. I am live on YouTube. Okay? So if you need some help, go to my YouTube channel and you can binge watch all of the videos that I've put up for different topics, whether it's writing chemical formulas or balancing chemical reactions or stoichiometry, whatever the case may be, you can go binge watch my channel, YouTube channel. Learn chemistry with Professor TK the Chemist. Learn chemistry with Professor TK the Chemist. Okay? Have a good one, guys, and thank you all so much, and keep pushing.